A ball starts at rest and rolls down a hill with a constant acceleration of 6 meters per second squared. The ball rolls for 8 meters. How long will it take and what will be the final velocity? We're going to underline some important things, including the ball starts at rest. It has a constant acceleration of 6 meters per second squared. The ball rolls for 8 meters, and we're asking ourselves, how long will it take and what will be the final velocity? We are going to write down the 5 things that we need to figure out. Our displacement, initial velocity, final velocity, acceleration, and time. We know the ball starts at rest, making our initial velocity 0 meters per second. It has a constant acceleration of 6 meters per second squared, and the displacement is 8 meters. We need to figure out how long it will take and what the final velocity would be. Is displacement equals initial velocity times time plus 1/2 times acceleration times time squared. I can cross out the first part of the equation because anything times 0 is 0. I have to have time by itself, and that equation will become time equals the square root of 2 times displacement divided by acceleration. I'm going to plug in my numbers, making the square root 2 times 8 meters divided by 6 meters per second squared. Now, using dimensional analysis, I'm going to solve the equation. 2 goes on top, times 8 meters on top, divided by 6 meters on the bottom, and seconds squared on the top. The squared cancels out because we are taking the square root of it. The meters cancel out because there's one on the top and the bottom. So plugging into my calculator, 16 divided by 6, I get the square root 2.667. Take the square root, and it equals 1.63 seconds. So we know our time is now 1.63 seconds. Now we need to figure out our final velocity. Using our acceleration equation, acceleration equals final velocity minus initial velocity divided by time. So I need to manipulate the equation to get final velocity by itself. I'm going to multiply time on each side. A times t equals VF minus VI. I'm going to add VI to each side. Acceleration times time plus initial velocity equals final velocity. final velocity equals 0 plus 6 meters per second squared times 1.63 seconds. Using dimensional analysis, I'm going to plug in my numbers. 6 meters on top, .63 seconds on top, plus 0. The 0 cancels out. I'm going to multiply 6 times 1.63, and in this second squared, 1 second cancels out because there's 1 on the top as well. So final velocity equals 9.78 meters per second. I'm going to fill that in where the question mark is. So as you can see, we figured out how long it would take for a ball starting at rest, moving at a constant acceleration of 6 meters per second squared down a hill for 8 meters. It would take 1.63 seconds, and its final velocity will be 9.78 meters per second.